right, so when you're looking at the second flow chart here, the back of your flow chart, this time we're going from name to compound. We're still going to ask ourselves the first question. Is it covalent, ionic, or acidic? And the way you're going to tell acidic is it's going to end with the word acid. And our covalents and ionics are still going to be the same rule. They're nonmetals and metals. You just have names instead of symbols. You're just going to look them up on the periodic table. Covalence is going to be kind of easy. You're going backwards. Whatever they give you, if they give you mono, you just write down 1. If they give you di, you write down 2. It's simple. It tells you exactly what to write. If you are doing ionic, you have to get charges and then build compounds. Okay, this is kind of what we were doing backwards the other day. So we're going to have to build based off of charges. When you have a Roman numeral, the Roman numeral tells you the charge. So if you look on the periodic table, you won't know its charge. So that's the one where the Roman numeral gives you the charge, and we're going to build them together. And then acids are going to be, once again, looking up. So if it's hydroic, we're going to go to the periodic table, unless it's this polyatomic ion without oxygen, the cyanide. If it's ic acid, we're going to look for 8s, polyatomics that end in 8. If it's us, we're going to look for polyatomics that ended in ite. Okay, so it's all working backwards. Bless you. So let's take a look at this first one, sodium sulfide. Sodium is number 11. So if you find it, are we going to be ionic, covalent, or acidic? We are going to be ionic. And sulfide, if it ends in IDE, is it a polyatomic ion or an element? Element. Okay, polyatomic ions, there are 3 polyatomic ions that end in IDE. Maybe flip to the back of your thing. Let's find the 3 polyatomic ions that end in IDE, because it's sometimes weird for kids to find. So there's hydroxide. So that's, some kids think that's hydrogen or something. So there's hydroxide, cyanide. There's one more, guys. What do you see? Peroxide. That's O2 minus 2, right? Okay, so put a little note next to those polyatomic ions, because those ones, if it ends in IDE, it's not an element off the periodic table. Otherwise, everything else is an element off the periodic table. So here we have sodium sulfide. So now we look to the periodic table. Find sodium. It's a group 1 metal. What charge is it going to be? So it's going to be Na plus 1. Sulfide, it's sulfur. Find it on the periodic table. I think it's 16. What's its charge? Minus 2. So how are these going to go together in order to add up to a total charge of 0? Bridget? And then a single S. Because of the pep assembly today, I'm going to skip the your turns, and we're going to just keep doing the practice ones, and then you guys will have time to start doing your work, okay? But so ask questions if you have them while we're working here. Copper 2. Do you have to look copper up on the periodic table and find its charge? No. So if you guys see this Roman numeral, you should know right away, first of all, it's ionic, because that's the only one that gives you that. And 2, it had to have been a transition metal, because that's the only one that gives me that. And so if it gives me that, that means it's a copper plus 2. Now I look at the second name. Second name ends in IDE. Is it one of my 3 weird polyatomics? No. So where is it? It's number 15 on the periodic table. What charge does phosphorus like to form? Minus 3. So what's this going to look like? Cu3. P2. So how did I do that? Well, this has to add up to a total charge of 0. Between 2 and 3, the smallest common multiple is 6. So I need to multiply this by 3 and this by 2 in order to get the charges to add up to 0. So now 2 times 3 plus 3 times 2 gives me 0, and those are negative. Everybody okay so far? So the next one, I have dis and I have hexas. What does that tell you right away? It's covalent. How else do you know? It's carbon and it's hydrogen, two nonmetals. Okay? So one, it's covalent. So if it's covalent, if it says dicarbon, what do? C2. Hexa. What's hexa? 6. And hydride, you have to go back and look and find the element. So it ends in IDE. Go back and find that element. It was hydrogen. And hexa means 6, you guys said. So you just do what it says. So covalents are probably the easiest because you don't have to look at the periodic table. You don't have to, well, you might have to if you don't know the elements symbol, but it's pretty simple. Okay, next one, strontium is number 38. So what's this going to be here? Strontium has a +2 charge. Now, is it ionic, covalent, or acidic? Ionic, because it's a metal, and we know it's charged to start off with. Which kind of ionic is it? The transition metal or the group 1 and 2? Group 1 and 2. And then we look at the next guy. It ends in ITE. If it ends in ITE or 8, what should your brain automatically think? Polyatomic. So find nitrite. Everybody find NO2 minus 1. So now we have to put this together. Nitrite is one thing. So it gets to stay together as one thing. We don't break it apart. So when we do this, we're going to need 2 nitrites. Everybody see that that's a -1, so we're going to need 2 of them. We're going to use parentheses to show we need 2. So we're going to do 1 SR and 2 NO2s because I need this whole thing's a -1, this is a +2. To add up to a total charge of 0, I have got to have 2 of these. You do not turn this into, some kids want to make this like N2O4. That means you just like made a new compound. We want to say we have 2 NO2s, not a new compound that you like decided to create. Okay? So down here for our acids. It ends in acid. That makes it really easy to be like, oh, dude, that's an acid. Then it's carbonic. So remember, if we look at our flow chart, if it was a hydroic, we do this. If it's just ic, we look here. So it says look at the root and charge on the polyatomic ions sheet. So find the polyatomic that originally ended in 8. Oh, wait. Am I on the right thing? Yeah. So find the original polyatomic. What is it? It's carbonate. So CO3 minus 2, I think, right? And what's the thing that's missing? What always goes in front? Simon? H. What's the charge on hydrogen? +1. So if we go to build this, what will it look like? CO3. Let's try the other acid just because it's a little bit different. So this one is a hydroic. So if it's a hydro, it's not a polyatomic unless it's like the cyanide, the one that doesn't have oxygen in it. So where do we go to find this center part? Periodic table. Okay, so this hydro means go to the periodic table to try and figure out what's going on. And you look up its charge. So what's the charge on chlorine? -1, I heard somebody say. So you find the root. So you look for chlor, and you're like, oh, there's chlorine. Okay? And then chlorine is in group 7. Group 7 wants 1 more electron, so it's going to be a -1. And what's the beginning part of every acid? Hydrogen, which is a +1. So this guy is HCl. So what I was thinking is that you guys